Okay, welcome back to part 2 of the Solidworks tutorial. I'll be continuing off where I left off. Now, we've already completed the first set of, guide curves on the front, and we'll now go to our next plane, which is intersecting the front wheel. Now, it's the same process pretty much the whole way. I'd like to create a guideline that intersects both the vertical splines and the horizontal splines. That way I can see the general distance and it's easier to connect my guide curves to them. Now it's just a matter of kind of fidgeting with the references of this line and making sure they're pierced to both the bottom one and the top. And I missed. I accidentally hit the right spline, so I have to delete that reference and try and pierce to the right one. There we go. And I think I messed it up again. Yep. I'm actually hitting the wrong curve. There you go. That's what happens. Now again, it's just kind of fidgeting with it until you get the curves to do the right things, and as you can see, it's messed up again. What the heck is that? So I'll delete the reference, pull it, or reference to the right spline, and there we go. There's a vertical guideline. Now we'll make a guideline for the horizontal section, piercing those two splines. Again, piercing is of utmost importance because if they are not pierced, then your curves will not work correctly when you are trying to loft. So you have to make sure all your points that are supposed to be connecting to different splines are adequately pierced. Now as you can see, we have kind of a funky egg shape going on, so we're going to adjust that curvature. Go in here and manually put it to 0 degrees so you get exactly flat on the top. Now we're going to do the same at the bottom. I'm going to pull that out because we like a flatter bottom to help protect against vortex shedding. It also helps go around the wheel a bit. Now don't worry about the bottom of the wheel. We'll make wheel fairings separately as a separate sketch later on in the design process. So your splines will go straight through the wheels. Don't worry about it. So now I'm just kind of looking at that curvature, seeing if I like it. Got a little bit of area there I could probably pull away. I think it's a little too excess. So we're going to pull that in. Just because we don't like extra cross-sectional area, it increases pressure drag. So the more cross-sectional area you can do without, the better. Now you could say there's more in there, but you got to be careful. You want a little extra room for when you actually close the loft. It's difficult to get around the front of the tire. And it's generally better to be a little more conservative in your approach than having a car that will come out too small for them to actually use. So now we'll mirror this half around the vertical guideline, and we've got exact curvature on either side. Make sure everything's pierced. It probably already is, but I like to go back and do it again. Just because if you mess up one stinking pierce point, it can mess up the whole loft, and you'll have to go back and troubleshoot why your loft is not completing. So there we go, that's our next cross section. We'll now do hide that plane so it doesn't get in the way, and show the plane that is intersecting our engine, which is the highest point on this car, so it is one of the areas that we need to define a cross section. So again, we'll start out with our guidelines. Now luckily this plane was defined on that point on the guide curve, so we'll just intersect it right there. Again, just piercing the points, making sure they all work, getting rid of other references that conflict. And there we go. That's the size of the cross section for this one. So again, we'll start with half and adjust the curvature appropriately and then mirror. So we'll start off. I like looking in the back or just offsetting it so I can see it better. And we will hide some of the other sketches, or we actually can't do that while we're in the sketch, so we'll just forget about it. Now we're manually adjusting this to 0 degrees, so it's perfectly flat on the top, and we have smooth curvature connection between the two halves. Doing the same on the bottom. Now because we're a little closer to the back, we'll start bringing this to more of a oval shape and less flat on the bottom. We'll still have some kind of a flat, or some flatness on the bottom to reduce vortex shedding, but we need to bring it back to a smooth point or line in the back section. So we kind of want it a more round shape as we near the end. That looks good to me. So we'll mirror that. And it fits around all of our constraints, which is good. Just hide that curvature. Don't need it anymore. Make sure everything's pierced. Now, I may have said this in another tutorial, I don't remember. It is better to minimize the amount or the number of guide curves you will have. So each one of these cross sections I'm defining is a guide curve you use in the loft. The more you have of them, the more or the less smooth your body will result in, because it has to conform to each one of those guide curves. So it's able to make a smoother transition between less, as we've seen in the spline, where if you have less points, it's a smoother curve than with more points. That's the same here. You want less guide curves. So you only want to put them around the most important areas of the car where you actually need to define them. So now we're doing the rear end. We just want to make sure we have a cross section in this back area, so we can help make the car wide enough for a rear wheel fairing, and so that the body, when you loft it, doesn't loft through the rear tire. And now we're just going to delete some references that are conflicting. There we go. Okay, we'll do half again, just adjusting the curvature. And as I said before, the bottom doesn't have to be as round anymore because we're coming to the rear end. So at this point, we don't need it flat as bottom, and we just want the curvature to smoothly transition to the point or line in the back end. Now we want it still to have that exact flatness on the bottom, just so it's a smooth transition from the two mirrored sections, so you don't get some weird ridge on the bottom of your car. Same thing with the top. You still want it to be exactly 0 degrees, but it doesn't have to be as flat. It just has to get around that wheel. So now we'll mirror that. Looks pretty good to me. And again, make sure all your points are pierced. And I sure hope this audio is recording correctly, because I'd hate to go back and do this again. I haven't really tested it that much this time. So we're just making sure they're pierced. They look all complete. Now we will begin our lofting procedure. First we're going to hide this curvature because we don't need it. Hide the plane. We don't need to see that anymore. We've got our overall body shape. So to begin, we will put a 3D sketch. Click under the sketch, 3D sketch, and then you'll want to make a point right on the front, right where your four curves meet. and then make sure it's there. Coincident, you want to make sure it is piercing or coincident with all of your curves, just to make sure. It probably already is, but it's just good to have it as reference that way, because again, Solidworks is a little finicky sometimes whether a point is actually part of the curve or not. So now we exit the sketch, then click on the sketch window. So now you can start a new 3D sketch. See how it says 3D sketch 1, 3D sketch 2. You want them to be separate sketches. So now you create a point in the back end. Again, a separate sketch is the first sketch. And make sure they're coincident with all the splines connecting to the back. Now, there has been some research we've done this year as to whether a point or a line in the back of the car is better. You'll have to do more research. We weren't able to get really good 3D parameter studies in regards to that aspect. My hunch is, as long as you maintain smooth curvature, either one will be beneficial. But now, okay, we're going to convert our entities, so we're going to start a new 3D sketch. Click one of our horizontal guidelines, hit convert, and hit OK. Now we are going to start a new 3D sketch. So now we're on our fourth 3D sketch. Convert entities. We're going to do the top guideline. Hit OK. Exit sketch. Make sure we start a new sketch. So we're on 3D sketch 5. Convert entities. Do the right guide curve. There we go. Now we're doing this. We're going to do it for the bottom as well. We're doing this so when we do a loft, we can select each curve individually, as opposed to the original had a sketch of the top and bottom curve and a sketch for the left and right curve. So now we're going to go to loft. We're going to start with our profile with the front point. So we go down to 3D sketch 1. Then we're going to select the sketch that defines that front guideline. Then the next profile. You have to do these in order. Then the next, and it looks kind of funky right now, but it will work itself out. And then you get to the back. So it still looks funky, but that's what guide curves are for. So we're going to just select all of them in a counterclockwise manner. Just want to make sure it does it in order. And as you can see, this is a problem we have commonly when we loft. It looks like it's working. It goes through all the 4 guide curves, but it just kind of jumps off the profiles themselves. So you have to delete a couple and just kind of see which combination of guide curves will get you the correct shape. So I deleted my left and right one, and as you can see, it's still maintaining that left and right guide curve, but it is now completely enclosed on all the guide curves and profiles. So we'll call that done. And you have your complete body. It encloses the wheels. For the most part, you have to put a fairing on later for each wheel. Now we're checking the curvature. Look at that. Nice smooth curvature transition. We got a bit of a flat area on the top. We might want to look at that later, but it should be okay. The bottom is nice and flat. That's good. And we got sharp curvature in the front. That's just normal. Sharp curvature in the back. That's normal as well. But overall, it looks pretty smooth, which is good. Now we're going to add some zebra lines just for cool effects. You can see it's almost like a good visualization of streamlines in a way. It's not perfect, but I like to think of it that way, if they were perfectly attached. So now, this is the end of the 3D SolidWorks model tutorial. I'm Kenny Broberg, and thank you for watching.